Alrighty, we have Physics Chapter 2, Energy and Work. So, this is a simple review on how energy and work will be tested. And keep in mind that the MCAT doesn't test any calculus-based forms of graphs or equations, so it is the most simplest form, although albeit some questions really do dig into very wordy formats and you will have to wrap your brain around them. Now, starting with energy, we have kinetic energy equals half mv squared, so mass times velocity squared. Remember, the squared part only squares the velocity, and if you want to find difference in kinetic energy, you have to isolate half the same mass and then bracket around the v squared minus the other v squared. Okay, don't subtract the v from the v and then square that. That would be a big mistake. Potential energy could be due to gravity, or just typically due to gravity by mass times gravity times the height. The higher something goes, the more potential energy it has because it will drop and exert a force. There's also potential from elastic force. So perhaps you're pulling a rubber band apart, and when you let go, it releases all that energy and snap together. We also have the total mechanical energy equals the total potential energy plus all the kinetic energy, and that allows us to do many equations such as the total speed, the final speed of a moving car from a plane, and some rolling ball down an inclined slope. We also have conservation of energy that yields that any new energy inputted could yield either addition in the kinetic energy or potential energy, depending on the type of energy being applied. We also have work. So work is basically the force applied over a distance. Think about the work you have to do to push a box around. The further you push the box, the more work it is. In work, in a PV diagram, which is pressure times volume, the amount of work would be changing the component of gas, the volume, into bigger or smaller. If the work is done by the gas, the volume would increase in volume, and we say that work is done by the gas. And if we were to decrease the volume and squish it in, the pressure doesn't change, the volume. If the volume changes, then the work will be negative because the work is done on the gas. So positive work is done by the gas. Negative work is done on the gas. We also have power. Power equals work over time. Think about how much power your oven has, and that is basically the amount of work it does over time, period of time, and we can also convert that from energy into time. So note that work essentially equals the energy in total. So these are interchangeable. We also have net work equals the total kinetic energy, final minus initial. So that will work a lot better if you're working with kinematics and you want to skip over certain parts, because you could just apply using the work energy theorem and use kinetic energy instead as part of the equation to solve the velocities a lot faster. You can skip a few steps if time or distance weren't given. You can just straight up and apply the work energy theorem and use finals minus initial and get the velocity you need. Mechanical advantage. There are several simple machines that we can use. There's an inclined plane, a wedge, like a door stopper, a wheel to travel, a lever, simply to press down and using that fulcrum. We also have a pulley and screw, which uses rotational motion. Now, mechanical advantage pretty much sums up to be using less force over a longer distance. So you can't lift the box straight up, so you push it up a ramp to essentially make the job easier for you, but you have to do it over a little bit longer time. Think about pushing a wheelchair. Would you take the wheelchair, lift it up the stairs, or if you take a ramp, you just have to take some more time and get it up to a certain elevation, right? So that's the same thing in an inclined plane. Now, the net energy, changing energy of the object, the potential energy, will be the same, but the way you go about it will be different according to work, right? You can exert a little less force, but over a little bit more distance to yield the exact same work. Okay? So in mechanical advantage, the force that comes out of the system equals the over the force you put in the system. And the higher the advantage, the more this ratio is. There's no units to this ratio, because the more force you can get out of the system over the force you put in, the greater advantage it gives you. So in the case of this inclined plane, if I only have to exert like 50% of the force I need to push this box up the hill versus lifting this up, the force that I want to put out over the force, or the force that comes out of the system, or the force that comes in, I put in, it would be 2, right? If it's only 50%. So it gives 2 times as much force as I need to get this up. In a pulley, we have efficiency equals work exerted, coming out over the work you put in. That also equals to the amount of load times the distance divided by the effort you put in times the amount of distance you put your effort in. In a pulley system, you notice how there's 2 cables around this wire, and it pulls down the object. Now, because of the 2 wires as opposed to just the 1 of the rope that you're pulling, it pretty much pulls it twice as much. So you have 2 hands helping you, whereas you're just pulling 1 long length. Note that if you want, because they share the same wire, you will have to pull twice as long, twice the effort distance to get that load up to the desired distance, as if you were just pulling 1. If I only have 1 wire and pulling 1 object, I have to pull certain distance x. But if that wire, I can split into 3 hands now, it can pull the object 3 times easier, but I need to pull 3 times harder because there's 3 long helping hands helping me. Okay, so due to the work equation, the force you put in could be smaller, but the distance you exert will be larger. Just like how we said, pushing up a wheelchair up a ramp, you would take a longer time to get to that same amount of energy. Now, basically summed up, less force over a longer distance. And because of friction and other air friction or resistances in a system, there's no absolutely 100% efficiency. So efficiency is calculated like such: the work got out of the system divided by the work you put in. Like such, work done by the system and the work you put in by the person. Common questions will usually give you a pulley with multiple and ask you to use the efficiency given and to calculate the effort exerted by the person or the effort distance the person will need to do. So you can just load up this equation, multiply the load, which is the mass, times gravity to get the force. And we also have the distance you need to push, get it up, and divide that by the effort, the force, and the distance. So force and distance. So force and force. Okay. Now the load pretty much is mass times gravity almost always if you're pulling something up. Alright, I think that's about it. So Physics Chapter 2, Energy and Work is a very quick summary. You will see it in about 2 questions at most. It's not a huge yield, but if it comes up, you'll be ready Take care.